Hi everyone. Today we are presenting our project called the One Knob Vocal Plugin. This was developed by Nitin, Mike, Alison, John, and Sila for the audio software engineering class. The objective of the project is to have a one-stop shop and an easy-to-use vocal plugin. It consists of a single knob that makes vocals sound really good. It also consists of different presets for different vocal styles like rock, pop, club, country, and the user can also set their own presets. It can be used by amateur users. It can be used by people singing over karaoke, by musicians who want to put up their music on streaming platforms like Discord or YouTube. It can also be used for hobby production functionality, and because it consists of just a single knob and different presets, the users need not plug in like 10 different plugins into their DAW and then struggle with all the presets. The single knob does it for them. The motivation and inspiration for this plugin comes from FL Studio's Sound Goodizer. The Sound Goodizer also consists of a single knob and different presets, and this knob makes the entire mix sound much better, brighter. Nobody knows what it does in the background, but then its only function is to make the entire mix sound good. So this inspired us to create the similar kind of plugin for vocal mixing.
Here is the user interface for our plugin. We chose the name Voce Dolce, meaning sweet voice, and used a color scheme inspired by luxury brands such as Dolce & Gabbana. Like the Sound Goodizer, we opted for a minimalist design with a single large knob at the center of the screen. Users control the amount of processing they apply to their vocals by simply turning the knob. The value of the knob is shown at the bottom of the screen, with values ranging from 0 to 1. Users can select from a series of vocal styles using a drop-down menu at the top of the screen. The meters to the left and right indicate the input and output gain on both the left and right vocal channels. By clicking the button at the bottom of the screen, users can view all of the effects we've included in our plugin and adjust parameters as desired. They can even create their own custom presets and add them to the list of available options by tweaking the effect parameters and hitting the Save button. In exposing these more granular options, we hope to create an application that both novice and advanced users will find useful in their workflows.
The compressor consists of different parameters like post gain, pre-gain, threshold, attack, release, ratio, and makeup gain. The values for these parameters are set according to industry norms. The input-output gains are range between -36 to 12 dB, whereas attack is from 0 to 50 milliseconds, whereas release ranges from 0 to 500. The thresholds can be anywhere between -48 to 0 dB. The values from the knobs in the front end are used to set the input, makeup, and output gains. The knobs are also used to set the compressor's attack, release, ratio, and thresholds. The audio block is then processed and the context is replaced in the process block. A lot of thought has gone into setting the presets. Not all of the parameters of all of the plugins change when the knob is turned. Things like gate, de-esser, maybe the equalizer don't have variable changes in their parameters. This is the rock presets. In this, the threshold is set to -40, and the ratios, the releases, most of them will be static when the knobs are changed. The things that do change are ratio, post gain, and some reverb parameters, and also saturation parameters. This changes based on what presets we are loading. For example, if I load the country preset, here the room size is smaller, the width of the reverb is smaller, and there's a lot of variability in the mix of the saturation. The compression ratios are generally higher, but the range is smaller, and the EQ is mostly fixed. So a lot of care was taken into deciding what parameters can change and what parameters need to stay static. Also, gain staging was an issue, so that we had to take care of. uh, the post gain for most of these plugins do not change when the knob is turned. Only things like compressors and maybe sometimes saturation post gain is tweaked, but generally the gain staging is left to one or two plugins.
We built Voce Dolce using the Juice framework, as it allowed us to easily chain a series of audio effects together and link these effects in a customized user interface. We focused on the effects engineers most commonly use when mixing and mastering vocals, namely a noise gate, de-esser, equalization, compression, saturation, and reverb. Each effect is built as its own separate processor unit within Juice, and the audio processor graph object links them all together.
I will explain more on the data structures I use to store our mappings, store presets, and then how we communicate with the backend and the front end. So we use hash map to store the mappings, and these hash maps share the same ID as the parameters in the audio parameter state value tree. And we have to modify the normalizable range of Juice because it has a weird situation where it only allow increment mapping, but we need to have constant and decrement mapping too. And another problem of decrement mapping is that if we change the 3-value slider, we will have some user experience issue, and we need to change a lot of things, and it is prone to bugs. So we decide to add a button to flip the mapping. So this button can flip the mapping. So now it's a decrement mapping, and then we change back. We can change it back to a increment mapping. So we use Juice value tree for storing every state in the backend. So actually, state information is a little bit different to storing presets inside it. So for example, if we save the project in DAW, we are saving state information. So in the state information, we have to include things like which preset is selected in the selection, and is this on or off, advanced mode on or off. But inside the plugin presets, we only need to store the ranges and the audio parameters. And loading order matters. So sometimes, all of the loading happens in the backend, but the front end need to fresh accordingly. But and we are using change broadcaster to send messages to the front end. But a problem here is that the front end and back end is in different threads, and sometimes the order in the back end don't necessarily mean it happens in the front end accordingly. So for example, you message the front end, and actually the next line in the backend actually will be executed before the front end respond to the message. So we need to ensure this, and we need to call some of the steps, put some of the step into a different function, and let the front end call those functions after the front end is being refreshed. And some other orders in the code matters too. So for example, the slider attachment should be always created first in the constructor, or otherwise it will cause it trouble, like the value falls back to default when you reopen the GUI. Also, so for the presets and fonts in our plugin, we can use the producers add existing files as binary resources, and this binary data will incorporate to the plugin in compile time. And for tooltips, so every widget Juice provide is a tooltip client, and we can make use of that to give the user the information we want to give them. For example, we use the tooltip window to give the user where they are changing the range to. So this will make the user experience far better and with a simple step. But a problem here is that the default to the window of Juice, it always follow your mouse, and when you click it disappears, so we have to modify it to put it in the bottom left. Yeah, and that's all of the explanation of code.
The first manual test that we conducted included making sure that the plugin could build and also be used inside of each of the following DAWs: Ableton, Logic, Pro Tools, and Reaper. So the bugs that we encountered and fixed included first that the VST3 would not pass audio, whereas the audio unit would. And the reason for this is because the audio graph was broken for VST3 when we switched audio devices, because it was calling the prepare to play function multiple times. The second bug that we fixed with respect to this is that we couldn't get audio passing through a Mac operating system, and that was solved by basically deleting a few caching files and having the system re-trigger microphone enable prompt. The next manual test that we conducted was to ensure that we could hear the DSP processing per module. The third test that we conducted was that general DAW functionality would work in terms of saving presets and performing automation with the plugin's internal parameters. To solve that, we had to switch from an initial single user interface design to a design that features one user interface per DSP effect. And this allows automation to basically and preset saving to be performed. Next, we found that there was a order of operations with the threads for the parameter ranges, where there was a bug with the order of whether the GUI, the parameter range backend, and audio would change. And lastly, we found that some of the fonts we used in our plugin were not packaged inside of the executable once it was given to somebody else for use. And so we also made it a point to do that, as well as package the presets inside the executable. We also then ensured that the order of trying out various DSP modules was good for a user's workflow and would not cause any additional bugs. And then also ensured that the parameter ranges mapped between the one knob and the individual plugin parameters, as well as the amount of scaling, was actually being scaled correctly. Finally, we also looked into verifying that the delay compensation was working as expected, and we can verify that it is. So for future work, we plan to look into making an installer for the Windows and Mac OS operating system, as well as create additional presets and demonstrations of others using the plugin.